All right. So welcome everyone. I'm really excited to be here today, talking to you at the Chatbot Africa Summit, and share a little bit about my thoughts around the future of conversational AI, and where things are today, how we got there, and where ultimately in the perhaps not so near future we will end up, or at least I see us ending up. So I think it's important before we start talking about conversational AI to take a moment to reflect and think a bit about what is AI, or artificial intelligence. And it's a fairly recent concept in history. Obviously, before we think about machines that are artificial, we had to have machines, and machines aren't that old. Computers per se weren't really invented until sort of the end of World War II. And the question was posed, I think, for the first time by what is someone who's often considered as the father of computer science, a British man by the name of Alan Turing, where he posed the question of, can machines learn? And he came up with what is known today as the Turing test, where the idea is for a machine to pass the Turing test, it would have to be a Wizard of Oz type of experiment where a person is communicating, interacting with the machine, and has to, at the end, detect with quite certainty if they're talking to a person or a machine. And if the person can't tell if they're talking to a person or a machine, then that machine would pass the Turing test. So it's a very sort of qualitative way of measuring, is this a machine or not. The term itself, artificial intelligence, wasn't coined until about 8 years later, during a conference in Dartmouth College, where they first used the term artificial intelligence. And that sort of kicked off the idea in people's heads of, you know, can a computer be intelligent? We know that a computer can compute. We know that it can do math faster than any humans. We know that it can remember things more than we can. We know that it can correlate things faster than we can. Uh, but but intelligence is a lot more than just the ability to compute, the ability to correlate. It comes down to the ability to infer. So if I can do an addition, I can do a multiplication and a division, and I'm posed with another problem that requires me combining arbitrary additions and multiplications and divisions, is that something that a machine can figure out on its own? The ability to have empathy, right? A lot of intelligence comes in being empathetic to the other person that you're communicating with, understanding if they're understanding with you, and whatnot. So we started on our journey for trying to teach computers intelligence, and that we called it artificial intelligence. And for the first 40 years of that, it was mostly ruled by limitations in our hardware. We were building computers ever and ever faster, but they were still, compared to today's computers, small. They didn't have a lot of memory. So we spent a lot of time optimizing search algorithms. And we really thought of the problem of artificial intelligence as a big search. You put all possibilities either in there that could ever happen, and you try to find the quickest way to get to the best possibility. And still today, a lot of AI is related to a search problem. And these systems were either sort of search-based or rule-based, and we'll talk a little bit about that in a second. So at some point, computers and AI in general started to have an inflection point. And I think a lot of that got started by the fact that, many of you are familiar with Moore's law, that states that the number of transistors and resistors in a chip can double every 24 months, and it continued to do that. So we started getting, not only each one of our chips started becoming more and more powerful, but we also started networking those chips together and creating networks of machines and clouds, and being able to compute and have computational power that we could only dream of, and data that we could only dream of. And that has really helped boost AI to a place where we are today. Even so, during the 90s and early 2000s, and still today, there are two main camps of AI. They're what we call the rationalists and they're the empiricists. The rationalists believe that AI, the best AIs are the ones where humans transfer their knowledge into a computer and then the computer exercises that knowledge. Some example of that are rule-based systems, or ontology-based systems, or graph-based systems, where we as humans are constructing graphs, constructing knowledge, encoding it in the machine, and then the machine uses that knowledge to process new inputs and interpret it. The empiricists, on the other hand, believe that, well, that's too much work and I'm too lazy. I don't have time to sit there and teach everything that I know a computer. My kids learn things without me teaching them. They just watch TV or they go out and talk to other kids and they come back and they've learned that. So computers should really be able to learn by observing. So if I feed them enough data, if I feed them enough audio, or if I feed them enough pictures of a cat, the computer should be able to, when I give them a new picture, say, hey, that's a cat. Or if I give them a new piece of audio, say, hey, this is what this audio transcribes to. So those are the empiricists. The reality is that most AI systems, successful AI systems that are deployed today in production are a mixture of these two fields. They balance a little bit of rationalism with a lot of bit of empiricism. And usually the rationalism comes to kind of tame the empiricism or the empirical systems. We've had, with the advent of neural nets, combined with the faster processing power of GPUs and clouds and TPUs, and just the vast amount of data that exists digitally today, everything from Wikipedia to every movie and thousands and hundreds of thousands of books that are available to be processed by these computers, have really made a huge impact, not only in AI, but specifically in the area of natural language understanding. Before we get into some of the examples of how AI is used in banking and finance, I think some economists who are way smarter than I am try to look at what is the impact of AI today and what will be the impact of AI in the future. And they came down to the conclusion that AI has already had a larger monetary impact in the economy than the internet, the telephone, or even energy per se. So that is a significant impact. And we only see that as growing up to $1.2 trillion by 2035. So it's already changing the way we live our lives everywhere, from a website that you visited or Netflix when you're using it. In banking specifically, there are successful AI systems being deployed to detect money laundering. There's, most of the trading out there today, a lot of it happens algorithmically, and that is using AI, different types of AI, fraud detection in other ways. There are many AI systems being deployed in financial institutions. Regulation and compliance, as you'll be familiar, there are many systems that are sitting there monitoring our emails, making sure, and our phone calls, making sure that we're not violating any laws or rules, and helping us create a safer and proper working environment. Risk assessment, when you're trying to offer a new loan and you want to try to assess how risky that is, there's many AI systems, CRM systems, and of course our favorite, virtual assistants, where we believe that these new advances in AI have really made a huge impact in transitioning us from the types of assistants that existed 10 years ago to the types of assistants that we're able to offer today. And in that, it is my belief and the belief of Casisto that not all virtual assistants, not all conversational AI platforms are the same. You have, and this is a little graph to sort of help you understand that. On the bottom left-hand side, you have what we call a bot, which is short for robot. And that's just a piece of software that's running in the background and processing data and doing things for you. The next step over that is the chat bot, which is really an FAQ type of system where you answer a question and it gives you, okay, look at this web page, or it's more directing you from one place or another, and often can feel very frustrating. When we graduate from that, you get into more of the realm where we build our virtual assistants, which are the conversational agents. These conversational agents can actually engage with you in a multi-turn conversation. They can talk to you about multiple topics at the same time. They can actually get things done for you. So instead of just offering you a website or a link to click, they say, well, you want to transfer some money? Who do you want to send the money to? And, I'll take care of this for you. And then graduating all the way into what we're calling the cognitive virtual assistant, where the focus is not just on the experience that the virtual assistant provides, but now providing a personalized experience. When you come and talk to me, Mr. User, you are not Mr. User, you are Sasha. And I know exactly who you are, what your preferences are. I can anticipate your needs. So before when you ask me for your balance, I already know it's because you want to send your daughter her allowance, because you usually do that. And I'm going to offer that to you as the next thing. Or I know that you're really concerned about your budget and you haven't really looked into it for a while. So I'm going to let you know that you are almost overspending on your restaurant budget. And I'm going to try to make sure that, you cancel those reservations for this week because you really want to save them for next week. So we really see the cognitive virtual assistant as being deeply personalized and providing to you an experience that not only is useful, but it feels personal to you. It's something in between, talking to your banker at the store, at the actual agency, as opposed to an ATM or even a mobile application. So that's sort of how we see the transition of the different virtual assistant conversational platforms that exist out there. So that gets us into the topic of AI, right? And there's two types of AI systems, roughly. So we talked about the different fields, but there's also sort of narrow AI systems, which is what most systems that you use today, and pretty much every single one of the examples that I showed you are narrow AI systems. And by narrow, we mean that they are AIs that are trained for a particular field, so they know how to do a specific task. Let me give you an example. So if you took an AI that was built for anti-money laundering, and you had them go answer the function as a virtual assistant, it probably wouldn't do a very good job. In fact, it wouldn't do any job at all, right? Where if you think of a person, you could take a person that's working under anti-money laundering and move them into a call center or a chat center, and they'll probably be able to pick up and get a conversation going and very quickly understand what are the most important things. The difference between the narrow AI and that person is what we call a general AI. So we believe that when we reach a point when our AIs are general, so they can be trained on one thing and then they can do something else and they can learn new things on their own, and they can make these abstractions and inferences, that's when we will reach a general AI. And I still believe, even though we have made a significant and fantastic strides in our narrow AIs, that it's going to take us much longer to get into a general AI type of framework. And I'll tell you a little bit about how I believe we might get there one day. So these specialized AIs, and there are many famous examples, right? Obviously, if any of you have interacted with one of our virtual assistants, we think they're a fantastic example of what a narrow AI can do. But there are other ones out there that you use on a day-to-day basis. You might have interacted with your Google Home or your Alexa, or you might have been surprised to see Amazon predict that thing that you really need to buy tonight for you. And all of these are examples of narrow AIs that you will come across on a day-to-day basis. Um, and last but not least, I think we can talk a little bit about the different areas of research and development that are specific to conversational AI. And these are any conversational AI system or interactive system ends up breaking down into three areas that are sort of the foundations of any interactive system. At one point, it needs to be able to understand what you're saying, right? So as you express yourself to the machine, either by talking to it or sending it a message or an email, the machine needs to be able to take that message and convert it into something that it can understand. And a lot of research goes into this understanding. Some examples of, and that's where we've made significant strides in understanding. So you might have heard things like BERT or Roberta or GPT-3. These are famous large vocabulary, generic language models that have had a huge impact on natural language understanding and natural language processing in general. They've been able to outperform humans in many, many tasks. Then the other area is around reasoning. So just understanding something is not enough, right? If I understand what you want, but then I can't do it for you, or I can't, if it's ambiguous, I can't go back to you and disambiguate it, then that's not enough. For a conversational system, you need to be able to understand. And then once you understand, you need to be able to decide what to do next and have this knowledge representation. So that area is often referred to as reasoning. So you take an understanding, you're going to reason about it, and you're going to decide what to do next. And what you decide to do next might be you're going to call some web services to get more information. You're going to say, well, I really don't have enough information. I need more information from you, Mr. User. So you're going to generate a disambiguating or clarifying question that you're going to send back to the user. So there's a lot of research going in on how to do this automatically and not automatically. And then finally, once the reasoning decides what it wants to do next, it needs to communicate with the user again, right? So we go from understanding, reasoning, we decide what we want to do yet, but now the machine generated something. I really want to ask this user when she was born. So that's where language generation comes in. The machine has knowledge, but it needs to present that knowledge in a way that we can understand, or in language. And again, we've made fantastic strides in generation. A lot of generation systems are still template-based, where one of us comes in and creates this little template, and we let the machine go in and fill in different slots or combine different templates to create a story. And eventually, and now we're also doing things where the system can actually generate the entire sentence from scratch on its own. So these are some of the main areas that we look at and we're studying in conversational AI that help us create the type of solutions that we like to see deployed today. So finally, if I were to make a prediction of how, I can't predict when, so I'll stick to how we will reach a general AI, I would have to say that the artificial general intelligence will actually be invented by a machine itself. So I think we're going to teach machines how to get to a certain point, and then they're going to evolve into the general artificial intelligence. So anyway, that's the way I see it. You're welcome to disagree with me. You're welcome to come and talk to me about it. I'd love to hear your thoughts. And if you have any more questions, you can reach out to us at Sales Like Assisto. If you want to be inspired, these are some of my favorite books. If you actually would like some nonfiction books to inspire you, feel free to reach out to me, and I'll be more than happy to make some recommendations for you. Thank you.